Hello, dear friends. About 6 years ago, there was a bit of a buzz about Nixie tubes making a big resurgence, and I ended up buying a bunch of them from the Ukraine. Why there will be explained later, but there they sat, festering on my shelf in my mind till late last year. So what is a Nixie tube? Quite simply, they are a primitive number display developed in 1955 by the Burroughs Business Machine Company. And although William S. Burroughs, descendant of the founder, went on to become probably America's best-known beat poet, there is no ode to Nixie tubes that are known to exist to have been penned by him. It is one of the great mysteries of literature. Where was I? Okay, let's start with something you might be familiar with. Before LEDs, simple AC power indicator lights on stuff were these little neon bulbs that had a very familiar orange neon glow amidst two little electrodes. They need about 170 volts peak to turn on, and matches it pretty well with what we call our 120 volt power lines. Interestingly, they really only glow from one electrode, let's call it the cathode, okay, at any one moment, based upon which way the current is flowing. The reason we see the glow surrounding both electrodes is that in North America, AC power current flow switches 60 times a second. Fun times, eh? So what if we made a neon tube that worked only with DC current flowing just one direction, but with 10 cathodes, and each one in the shape of a digit, A through J, right? No. Better yet, 0 through 9. Huh? We just invented a Nixie tube. We're rich. Not so fast. During their heyday, Nixies were generally considered too expensive for use in the mass market consumer goods like clocks, but industry and the military loved them until they were replaced by LEDs in the 60s, except in the former USSR, where they either thought LEDs were just some fad or some capitalist tool. But consider that also at that time and later, USSR developed some very sophisticated stuff still using vacuum tubes. By the way, Nixies are not vacuum tubes. We didn't talk about cold cathode and thermionic emissions, and I don't think we will at this time. I also suspect, based on what I know about Soviet economic planning, there was some huge factory that kept cranking them out long after anybody there actually needed them, and that is why and how I found my lot of tubes in the Ukraine. See, I eventually got there. Today, they're being made again laboriously by some guy in the Belarus to feed the resurgence craze. These new ones are big, and they're beautiful, and they're $200 a digit. So I could have made a bunch of clocks with the pile of Nixies I had, but like I sometimes say, go big or go home. So I set forth to create a clock with 24 digits. Trust me, it made sense at the time. Controlling 24 times 10 cathodes, plus some variable fancy LED underlighting, plus the, if you pardon the expression, colons, also variable brightness for each one of those digits, may sound problematic to you, and you'd be right. So here's what I did. I paired up Nixies along with our fancy LED underlighting and colons on a board, along with a $3 Arduino computer to control them. Each board has a hardware settable address code, and that way all the boards can have identical software. Now a separate and insanely more expensive, I think that was like $6, 8266 computer that can connect to the internet and its series of tubes, and the time of day. So they can get the time and then send commands to all 12 boards simultaneously. Now, since each Nixie board has a unique address, only the one addressed by the command. Hey, this command is for me. All right. Only that'll decode it and execute it, and all the other boards will just simply ignore it. I found a great design for a high voltage, which is like 170 volt, power supply, and there was a guy nice enough to make the PC board design available. I ordered the boards, I ordered the parts, tiny parts, put them all together. Bob's your uncle. Worked great. I built a frame from some maple we cut down on our property because you can't really trust wood you didn't see grow. That's pretty much it. The circuitry and subsequent PC board layout was done with the amazing and open source KiCad, which was mainly developed at CERN laboratories in Switzerland, where apparently when they're not finding God particles or eating chocolate or trying to make tiny little black holes that might end up destroying the universe as we know it, they actually write some great software. Who knew? My first batch of boards had some snap-off strips I wanted to use for the, if you pardon the expression, colons. And there were a few problems on the main board. There always are the first time. These are problematic enough that I went for a second production run, plus, without the colon strips, which works out pretty good, I was able to get a little more tidy, compact design, which all means a much cheaper board. I needed to make some diffusers for the fancy LED underlighting. Creating a model in OpenSCAD, which is another great open source program, was easy, and I 3D printed them in no time. Similarly, I cranked out some mounting brackets to mount the Nixie boards to a rail. Software-wise, I'm still working on possible animation schemes, but I've got it marching around every minute in a couple of changing patterns.
The last 5 seconds before each minute are discreetly displayed, and on the hour and half hour, there's a splashy wipe. My next priorities are adding a web server for alarm clock and stopwatch functions. My latest development was to implement a more constant seconds indicator, sort of like a tick. So I went ahead with a throbbing colon. Now that I've completely destroyed all sense of decency, I'll bid you a fond adieu, or as the French tend to say,